The interesting geometry of a Bose-Einstein condensate of helium containing both positrons, electrons, neutrons, and protons. Okay, so there's one step more that I went in my model, and that's to say, well, actually, there's only just electrons. Okay, the reason for that I'll get to, but if you go, okay, so there's 3 quarks and a proton, they're actually just 3 electrons. There's 3 quarks and a neutron, actually they're just electrons, and make an electron-Janus particle, both positive and negative sides to it, depending on its orientation with respect to the nucleus. If it's pointed out, the outside surface is negative, the inside surface is positive. So all of a sudden, my model's changed. I've got one thing in my model, and that is a Bose-Einstein condensate made just of electrons. And in helium, it would have 2 protons, which is 2 3s are 6, so 6 electrons there. And the neutrons are again 6, so that's 6 and 6 are 12. And then you have the 2 electrons and 2 positrons, which are all just electrons. So 16 in all. So if you have 16 electrons in helium in this new Bose-Einstein condensate of supersymmetry prior to the Big Bang, then you can start to develop a concept of unity. And what I ended up doing is looking at the emission of alpha particles from the Bose-Einstein condensate as a supersymmetry inversion system that generated both speed of light, and based on the kilojoules per mole binding energy of the alpha particle release from the Bose-Einstein condensate made of helium. Interestingly, the number corresponds to the speed of light, or at least 10% of that kilojoules per mole number corresponds to the speed of light. Not only that, the geometry of the right-hand rule of electromagnetism is inbuilt within that cross-space symmetry. And there's also something else that's quite remarkable. The 16 electrons, if you have 12 going out as the alpha particle and 4 going in as generating the Planck lengths, then you have this model which idealistically provides an understanding of 3-to-1 ratio, and that's seen again in hydrogen, where you have 3 electrons within the nucleus and 1 around the outside. So you've gone from this concept of a Bose-Einstein condensate to the concept of geometry in hydrogen, the first element of the periodic table, which has an asymmetry to it, and therefore it has inbuilt within it the opposite of 3 in and 1 out versus the alpha particle 3 going out and 1 going in as the equal and opposite type of concept in the supersymmetry inversion model allows for the generation of the Planck length after 13.8 billion light years of these electrons migrating inward versus the 6.25 times 10 to the 34, which is the distance light's traveled at, near 300,000 kilometers per second after 13.8 billion light years. So the model not only stacks up from the concept of geometry of light, the speed of light, the ratios of dark energy, dark matter, and matter, virtual particles. It has within those kind of terminologies a universal functionality, going back to what was prior to the Big Bang. So I don't look at the Big Bang anymore. I look at a supersymmetry inversion model, and that model has given from at the start, 75% alpha particle generated from the helium Bose-Einstein condensate to 25% of the electrons traveling inward to form the Planck length, which is this dark matter. So dark matter to me is Planck lengths, and dark energy is the alpha particle generated at the point of supersymmetry inversion 13.8 billion light years ago. So my model is different. Yes, actually it stacks up, because if you look at the decay rate of 10 to the 17 seconds for the alpha particle, after 13.8 billion light years, there's been 10 to the 18 seconds of time. What you get is 7.26% decay of the alpha particle into matter and virtual particles, or what I consider radicals. So this model that I've generated based on a moment of, I would say, flash of inspiration, has really taken me to the point of understanding what dark matter, dark energy matter, and the supersymmetry inversion of the Bose-Einstein condensate 13.8 billion light years ago. So, yeah, crazy as it may seem, I think my model stacks up.